Okay, so now we're going to look at rationalizing surds. So, rationalizing surds. A lot of students actually find this a very difficult task to accomplish. However, I feel like it's probably one of the most important um, subtopics in surds, and the only reason being that it kind of knocks out all your previous exercises in the one go. So you got to learn how to do binomial expansions. You got to know how to do simplifying of surds and how to expand using multiplication as well. So it kind of sums up everything and rationalizes at the same time. So the point of rationalizing, well, in this case, we're going to rationalize the denominator. So the point of rationalizing surds is that we would like to make the denominator without a square root anymore, so without a surd. So a simple case would be, imagine we had 3 over root 2. Actually, there's 2 types. So we're going to have a look at type 1. So this is type 1 case. And then later on, we'll have a look at type 2 cases, which is something like this. So the only difference is that I've got a plus or a minus. I've got an extra little bit on the denominator, okay? So as we can see, the top's still the same. It doesn't make a difference on the numerator. It's a denominator that's different. Okay, so we're going to focus on type 1 for now. It's not hard. Our aim is to remove this surd, and the best way to do that is actually to multiply by the exact same surd here. And the reason why that is, if we looked at previous videos, we saw that root 2 times root 2 actually becomes root 4, which essentially turns into the number 2 itself. And that's actually a very neat concept, because we've changed our surd into a whole number, which is the whole point of rationalizing. So we're going to times by root 2 here, and what you do to the bottom, you got to do to the top, so you also times root 2 there. Now, what's 3 times root 2? That's 3 root 2 over, what's root 2 times root 2? Well, we just worked that out. That's root 4, which becomes 2. That's it. That's your answer. Yes, easy. So let's do another one. Let's go with 4. Let's make it a little bit trickier now. Let's go 4 root 3 over root 6. Okay, what do I times by? Do I times the root 3 or do I times by the root 6? Well, remember, we're trying to rationalize the denominator. Okay, we want the denominator a whole number. We don't care about the top. The top can be a surd. It doesn't make a difference. So to rationalize the denominator, or I'm going to do the times by the exact same denominator. See, here I multiply by root 2, root 2. Here it's root 6, root 6. Okay, as before, we would multiply the top. So as I said, previous exercises, you should have done this already. So that's the good part of doing rationalizing. It kind of combines all your previous subtopics into one. So 4 root 3 times root 6, well, 4 times 1 is 4, and then root 3 times root 6 is root 18, over root 6 times root 6, that becomes 6. Now, you should always fully simplify. As we can see from this, that root 18 is actually root 9 times 2. Okay? And from previous exercises, again, that root 9 times 2 can get simplified to something like this, which essentially root 9 is 3 root 2. So 3 root 2 times 4, so rather than root 9 times 2, we're going to use 3 root 2. So let me just maybe do a little bit slower. So 4 times 3 root 2 over 6. And then 4 times 3 is 12 root 2 over 6. And then 12 over 6 is 2 on the numerator. So 2 root 2 is your final answer. Okay, don't think that just because it's a little bit lengthier than that it is a lot harder. It's actually not. It's exactly the same. However, you should know to simplify always. Okay, so that should be like a preliminary kind of topic for you. Okay, one more. So let's go with 3 root 6 plus 4 over 2 root 5. All right, what do I times top and bottom by? Yep, you guessed it. You could times either by root 5, but I'm just going to make it what a lot of people tend to do, which is times by the bottom. Okay, the whole bottom. There you go. Times by 2 root 5. Nice and easy. Now, remember, it's a binomial expansion, so all of this is multiplied by this, and this is also multiplied by this. Okay, we never had 2 terms on the top before. It was always just the 1 term. But now, since we've got this plus, we have to multiply both of them by this number here. So that's going to turn into 3 times 2 is 6. Root 6 times root 5 is root 30. Then plus 4 times 2 is 8. And then there's nothing attached to the root here, so it's just going to be 8 root 5. Over. Then what's 2 times 2? That's 4. What's root 5 times root 5? Well, the root 5's kind of cancel out. And what we get 5. Should have got the habit of that by now. 6 root 30 plus 8 root 5. Does root 30 simplify at all? No, it doesn't, because it doesn't go into any perfect numbers like 4, 9, 16 or anything like that. So the top stays the same and the bottom is 20. Now you do realize there's a common factor of 2 in all of them, so you should fully simplify that to 3 root 30 plus 4 root 5 all over 10. Okay. Now, we're going to look at type 2 cases. So type 2. Okay. The only difference between type 1 and type 2 is the fact that the denominator no longer has just a single surd. It has a surd with something else, another surd or another number. Now, what we actually look for in this case to multiply is by its conjugate. What is its conjugate? It's exactly the same number except a different sign in the middle. So for example, A plus B, and the conjugate must be A minus B. Okay? Or if you had A minus B, your conjugate is of course A plus B. Alrighty? So it's not too hard. All we do is multiply by its conjugate. So therefore we're going to multiply by root 2. See, that stays the same. A stayed the same. But then rather than a plus, you're going to use a minus. So it's going to be minus, and then B, and B stayed the same, so 3 and 3. There you go. Exactly the same, except one's a plus, the other one's a minus. Root 2 minus 3. What you do to the bottom, you go to the top. Alright, same thing as before. 3 times all of this. Okay? Alright, here we go. So then my answer is going to be 3 times root 2. That's 3 root 2. 3 times minus 3. That's minus 9. Over. Now, we learned something with conjugates. We've learned that A plus B times A minus B actually turns into A squared minus B squared. That's actually very handy, because now when root 2 times root 2, well, it's going to become root 2 all squared, which we realized was 2 already. And then it's just 3 times 3, which is minus 9. See? A, B, one's a plus, one's a minus. So root 2, 3, one's a plus, one's a minus. It's going to be the first one squared. So root 2 squared, which is 2, because the square root and the square cancel out. And then it's just 3 squared, and there's a 3 squared, and there must be a minus in between them. There must be a minus in between them. Perfect. So my final answer is 3 root 2 minus 9 over minus 7. And that can't get simplified at all because there's no common factor. Alright, let's try one more of those ones. So how about we'll go with a little bit trickier now. So 4 root 5 minus 2 root 6 over 3 root 3 minus 2. Okay, what do? Well, I multiply by 3 root 3. Rather than minus, I have to use now plus 2. Remember, just the sign changes. And what you do to the bottom, you got to do to the top. Alright. Now, in this case, because we've realized our denominator is easier to deal with, let's do our denominator first. So, what's 3 root 3 all squared? Well, 3 times 3 is 9. Then root 3 all squared, right? That just becomes 3. So it's 9 from 3 squared, and then root 3 all squared, which is 9 times 3. And then that's minus 2 squared, which is 4. So my denominator is done. That's from this rule up here. So the conjugate rule. A plus B times A minus B is A squared minus B squared. Okay, now the one that's a little bit harder. So we're going to look at a double binomial expansion. So all of this multiplied by all of this. Okay, you guys should remember how to do that again, but I'll do the arrows just for now. There it is. And then we're going to multiply that. Okay, so it's going to be 4 root 5 times 3 root 3, which is 12 from 4 times 3, that's 12. And then you got to do the roots together. So root 5 times root 3, that's root 15. 5 times 3, right? Root 15. Then we're going to do 4 root 5 times 2, and it's a positive 2. Okay? It's positive 2. So it's going to be plus, and then 4 times 2 is 8, and then there's no root here, so it's just root 5 times 1, which is just root 5. Alright, then we do that again. So now it's a minus times a positive. Well, definitely we know that's straight away a negative. 2 times 3, they're in the outsides, right? So you multiply outsides together, you multiply the insides together. So 2 times 3 is 6, then the insides. Root 6 times root 3, that's root 18. And then minus 2 times positive 2 is, again, negative 4 root 6. Let me just get rid of that. Rewrite that in again. Negative 4 root 6. Okay? And then we just simplify before we finish off. 12 root 15 plus 8 root 5. This can get simplified, but because I can see nothing else is going to get simplified, we'll just leave that for the time being. We'll leave it as minus 6 root 18, minus 4 root 6, all over. 9 times 3 is 27, take away 4 is 23. And that's it. That's my answer. So that's rationalizing the surds. Not very hard concept. Hopefully you guys found that pretty easy. Thank you.